Hello, everyone. Thank you for the very kind introduction, Celia. I have a lot of slides. I will try and get through them on time. Fingers crossed we make it. So yeah, my name is Mike Ambinder. Very happy to talk to you guys today about a science of game design. Really, for me, it's just an introduction to one way of thinking that I think will help us make better games. There are a lot of questions I have about game design, and I don't have a lot of answers, and I'd like more of them. And so this talk is really my plea to figure out more. We'll see if you agree with me by the end of it. So background on me, as Celia said, I started at Valve in 2008, a long time ago. I spent about 15 years there leading research efforts. Back then, this was before the field of UX existed. It was me and Celia and a few folks at Microsoft, and that was it. And now there are thousands of us, which is great. The field is young, but growing and incredibly impactful, and it's been wonderful to see. After Valve, I decided to go do independent research, and then last year joined a startup, a game studio trying to make games that can induce social outcomes, so positive behavior change in the world. So my official background, my technical background is in psychology. I wanted to apply knowledge methodologies from psychology to game design. That's why I went to Valve. But when I was there, I did a whole bunch of things. Lots of user research, UX design, game design, stats and machine learning. I'm a stats nerd. I love playing with data. Economic systems design, played around with non-invasive brain-computer interfaces. But really, I was curious about trying to use whatever tools we had at our disposal, whatever domains, knowledge from disciplines, methodologies, approaches, frameworks, whatever we could use to help us make more smarter or more informed game design decisions. That was the goal. And so I got to do that in a variety of ways and in a variety of contexts. This is a quote I like to put in basically every talk I give. It kind of encapsulates my I guess, ethos as a researcher. If it can be destroyed by the truth, it deserves to be destroyed by the truth. Sagan said this. And my goal with this talk, honestly, is to uncover some new truths. To the extent that they exist in game design, to the extent that there's an underlying structure, some underlying reality to game design, what would it be? And can we figure it out? So here's the outline, what we'll go through in the talk. I'll talk to you guys about exactly what I mean by science of game design. I know many people in this room are already probably practicing it and are already very good at it, but we can always do more. Always more questions to answer. Talk about its utility, talk about how we implement it, and then go through some specific examples of exactly how you put this into practice. So when I say game design, what do you think of it? Do you think of it as an art, a science, a creative endeavor? Likely some combination of all three. I imagine folks in this room are receptive to the notion of game design being a science, but lots of folks have difficulty with that, right? Game design is a creative endeavor, an artistic endeavor. The point I want to make here is that science can improve whatever art is present in game design. Science can improve whatever is creative in game design, right? Through scientific approaches, we can generate new data that informs the intuition and inspiration that generates art and creativity. So I don't see science as at odds with art or creativity, but it's a means of fostering and supporting both of them. So whatever magic goes into creating art or being creative, my bet is that you can get better in both domains by having a deeper understanding of the science, of the knowledge that science provides. I think this is the slide that has the most text on it, so I promise I won't make you read too much. But just so we're all on the same page with kind of definitions of things. Science, here's one definition: the systematic study of the structure and behavior of the world through observation, experimentation, and the testing of theories against the evidence obtained. Seems reasonable to me, but let me know if you have objections. And what's a discipline? An organized field of study or branch of knowledge with its own focus, methods, theories, and communities. So I'm defining them because I want to ask this question. Is game design a science or a discipline? Is it an art or is it a craft, right? Ultimately, of course, right, these questions don't end up mattering, but I do think they're useful framing devices to understand how people commonly tend to see things, right? What I want to know is, do we have underlying theories of player behavior that are specific to games, right? Like that's the fundamental question, right? Game-specific theories. Not theories we've acquired from other domains, and we'll get to that, but theories that are tied to games. So here's lots of things I don't know, right? What is an effective matchmaking scheme? And how would you figure that out, right? I have notions. You could measure aspects of teamwork, cohesion, cooperation, competition, but I don't know, right? Do any of us? If you do, please let me know. Actually, how do I get to see the rest of it? I have great examples that I cannot see because I cannot see all of my notes. How do you scroll? Okay. Thank you. Sorry. All right, they're actually not great examples, but you know, there are examples that I didn't remember offhand, so it's good to write them down. More questions. What is the most entertaining size of a team, or most effective size of a team in a PvP game, right? Is it 5? Is it 6? Is it 10? Is it 100, right? I don't have the answer. And again, I'm not sure anyone does. How much cognitive load can an experienced player, whatever that means, handle in Dota versus a beginner? Yes. No worries. Sorry, guys. Okay. How much cognitive load could an experienced player, whatever experience means, handle in Dota versus a beginner? How does that differ in Call of Duty, right? I know how to measure cognitive load and its relationship to other variables, but I don't have a load curve mapped out, nor why it would be what it would be, and how to manipulate it effectively. I'd love to find out. If somebody asked you, what's the single most important factor for long-term retention in a game? What would it be? And when does it change? Why is Fortnite or Roblox or Minecraft the most popular game in the world? Are they lucky? Are they good? Both? Could we know beforehand? Could we predict? Right. My thesis for this talk, right, is that if we approach game design with a scientific framework, we can start answering questions like that. Like, please argue against it, please send me feedback, but this is my hypothesis that I proffer to you. What are hallmarks of science? Science is empirical, right? It is data-driven. It is testable and falsifiable. It's reproducible, right? It happens more than once. It is predictive. We can derive future insight about the world. It is tentative, which means iterative, which means that we can alter it. When we get new information, our beliefs change. That's what science provides. It is systematic, so it is methodical in approach. It is quantitative. We take abstract ideas and turn them into measurable quantities. It is transparent and peer-reviewed, right? You don't take somebody's word for it. It is conciliant, which is a word you'll see again in this talk, which means harmonious with other disciplines, right? It works in accordance with knowledge that we possess. It is objective, free from bias. It generalizes. And my favorite, it is theory-driven. Although actually, they're all my favorite. I love all of these things. I love science a lot. All of these qualities are good qualities. And if research or work about games had them, I think we could make more informed game design decisions. So why do I think we need a science of game design? It's because games are different. They're a new kind of environment with a different set of constraints in the real world, right? We have different rules, different goals, different social dynamics, rewards. I believe players behave differently than they do in the real world, right? Like, this is the motivating impetus for the discussion around a science of game design. It's like, video games are something different. They are a new kind of experience, not one we evolved for, right? Think of the other social sciences, right? Psychology studies human behavior. Sociology studies group behavior. Economics studies incentives and resource allocation. What would a science of game design study? And could we generate game design specific theories for fun or engagement or matchmaking? Right, so this talk is predicated on that notion. You know, the games are different and that we would benefit from game specific insight generation. If you disagree, I'm very sorry, you have to suffer through the next 20 minutes, but it should go quickly. Here's the last slide with a lot of text. A science of game design is not just applying principles from psychology, economics, HCI, sociology, whatever. It is deriving and generating new theories which explain behavior that do not exist in other domains. So what are our game-specific theories? That's what I want to know. So let's put it up against the big guns, right? Physics, chemistry, biology. Physics, you know, we study matter, energy, fundamental forces, how they interact to produce motion, structure, change. Chemistry is the study of substances, right? Their properties, composition, and transformations, including how atoms and molecules combine and react. Biology is the study of living organisms, their structures, functions, development, evolution, and interactions with their environments. What is game design? What could it be? The study of play, rules, systems, and player experience. And all this happens in a simulated environment, right? For physics, chemistry, and biology, you know, I don't have them here because I want to make a direct comparison about their ability to make falsifiable predictions about the world. But because the structure of their approach is something I want to emulate, what we could do in games, right? In biology, we can explain the function of mitochondria, right? The energy source of the cell. We can explain it very well. Can we explain the function of rewards in games as effectively? right? How much understanding do we truly have around how rewards drive behavior in games? What is the most effective reward you can give a player, and why? And when does that change? And how much are you decreasing intrinsic motivation when you give them a reward? And does that matter? So do we need a science of game design? Well, let me ask a different question. What knowledge could we acquire that we do not currently possess? What kinds of questions could we answer? Could we get insight into what a good or a bad user interface actually is and how they shape player behavior, expectation, and sentiment, right? We have principles that we apply. What are the underlying theories that genuinely explain or predict behavior? Right? Games are immensely complex combinations of systems and dynamics and perceptual elements and interaction patterns which produce a profound array of impacts on the player. How much do we know or not know, as the case may be, about all of these impacts and about how various components of a game alter player sentiment in so many ways? Let's go back to art and add music and game design. Is there a science of art? Is there a science of music? Right? Art has, foreground and background and figure and the study of aesthetics. What is the analog in games? Right? Music has melody and timbre and harmony and rhythm. That rhythm makes you feel certain things, right? Like technically musical rhythm is the patterned arrangement of sounds and silences over time. It creates a sense of movement, pulse, and groove. It defines the length, timing, and emphasis of musical notes and rests. The rhythm can be harmonious or it can be discordant. So my question to you is, what is the rhythm of games, right? What are the beats and silences that work together to produce the rhythm of a game that makes someone feel engaged? Right? Rhythm is artistic, but it's also structured. It's also mathematical. Games are artistic. How are they structured? How are they mathematical? How are they explained? I want to understand what components of a game produce the rhythm, the feeling, the sensations, the experience that somebody has when they're playing a game. Here's an example. How does the presence of a single player mode impact the perception of a multiplayer mode in a game? Does your single player experience impact the rhythm of your multiplayer experience, or vice versa? Whatever that means. I want to know. I want to know how the components interact and how they create this holistic sensation of what it feels like to play a game, whether that game is fun or engaging or immersive, all things we will need to define. I want theories. That's what I want. Like physics has electromagnetism and gravity and the laws of motion. Chemistry has atomic theory and periodic table. Biology has evolution and cell theory. They are centuries of work ahead of us, right? Not saying we need to get where they are or get there specifically, but they can definitely serve as inspiration, right? How do we measure fun? Is it engagement, playtime, or something else entirely, right? What is the best matchmaking formula? Is it always a 50-50 expected win rate? That's what we use most of the time. Should it be? For UIs, right? When I was in grad school, we always talked about the proximity compatibility principle. Things that are cognitively proximal should be physically proximal. Makes sense. It's intuitive. When does it fail? Why does it fail? Does it matter? Think about theories of difficulty. We can measure if something is hard. What does it actually mean? Is it good hard? Is it bad hard? How can we tell? Retention. What factors drive someone away from the game or keep them playing? I want to know for a specific game and for a specific genre and how it changes over time. We are great at post-hoc rationalizations. How good are we at predictive assessments? Rewards, right? They can be variable or fixed. They can be time-based or event-based. What's our unifying theory of rewards? Does one exist, right? We have lots of principles we apply. We try and understand them. What is actually a reward, right? There are 150, 200 people in this room. We may have 200 definitions, 200 different definitions. Accessibility, there is great work being done in accessibility, right? Think about reducing cognitive load, improving legibility, whatever it ends up being. When is something accessible enough? And how do you define enough? Right? I want to know the answers to these questions, right? I want to know what our underlying theories are, not just what we borrowed from other disciplines, but what are unique to games, because games are unique. Games are very, very different. So that's why I'm giving this talk. I want to know the theories that explain how all of these elements of a game impact player behavior. So how do we do it? How do we create a science of game design? I usually have a slide like this at every talk too. Scientific method, one of my favorite things. It's the single best way we have of adding knowledge to the world. It's been around for thousands of years, and it has never failed. It works in every domain, right? You have hypotheses, you run experiments to test them, you gather data, analyze the data. That leads to an improved understanding of the world, we hope, a theory generation, which lets you make more hypotheses, and around we go. So here's my point. Game designs are hypotheses, right? Playtests are our experiments. We have other methodologies, right? But this is it, right? This is the scientific method applied to game design, right? This is how we make progress. When you think about game design, right, people often think it's just an idea, right? What is a game design? Oh, it's an idea I have for a mechanic, for a concept, for something we could do inside of a game. I disagree. A game design is three things. It's an idea, it's execution, and it's evaluation. It's not an idea, it's a process, right? You have an idea, you have to figure out how to actually put it inside of a game, and then you figure out if it is achieving its intended goal or not, and then you learn from that. That's what a game design is. It's not an idea, it's a process. If we do this, right, if we start thinking this way, we can start to generate all of those theories that I keep wondering about. We can better understand why the principles we use are the way they are, and how they are specifically adapted for games, right? I want to turn ideas into measurable and impacted variables that we can systematically manipulate. I want to be able to explain why players are doing what they're doing both now and in the future. What I'm looking for is a theoretically driven understanding for changes in player behavior. And I think we get there if we approach game design like this. So what do we need to accomplish this? You know, what do we actually need to put this into practice? Well, we need an experimental infrastructure, the ability to run experiments. It doesn't need to be fancy. Playtests are great experiments. So are updates to games, right? Obviously not as controlled as we would like, but we can make do. If we get the chance to run more controlled experiments, let's do that as well. We need to build theory, right? Take the extra step of extrapolation and aggregation of data into rationale. We want to operationalize concepts, turn ideas into measurable constructs. What is a measure of engagement or fun? We'll get to fun. We want our theories to work across games, to generalize, and understand when they work, and understand when they don't. We need to do it ethically, or we could, right? We can choose what to research and better understand its impact on players, and ideally, right, adapt in ways that are ethical and moral to the player experience. We need to be consilient, or have consilience with creative practice. It's that word again, I promised it would show up, right? We want to make sure the knowledge we add bolsters and does not hinder the creative process. And we have to share knowledge, right? Everybody gets to get smarter, right? So we're doing that today. We did it yesterday. But you know, there are thousands of publications that come out every year in our industry, and thousands of peer-reviewed articles, right? Every game is a publication. Every game is a peer-reviewed article. We have lots of data to draw on. Not access to all of it, all the things we could use, but enough to start building, enough to start trying to understand better why players are doing what they do. Of course, we live in the real world, right? There are obviously barriers to what is going on. We work at companies, most of us, not research labs. We need to support business goals. And this for sure is an idealized framework, right? For sure, not always practical. And this will take time, right? And there are many other, right? I have this slide because, right, let's be realistic about the world. But my point here, right, is that if my thesis is correct, and we can benefit from generating theories, right, we're going to be able to reduce risk and cost and time in game development. And all of those sound wonderful. And all of those sound like appealing ways to overcome these barriers. So here's the list of things I'm curious about. This is a short list. It's only kind of like 10 things. The actual list I counted, I think, is like 372 and growing. I'm happy to send it to anybody who wants to read a bunch of nonsense. Really, it's only here to prime the pump, right? I'm curious what you guys want underlying theories for, what things you want a deeper understanding or a better explanation for. So we will talk about a few of them. We'll talk about some work we did at Valve on economy design, how to measure luck and skill, reducing online toxicity, and yeah, we'll tackle the big one. I don't have a definitive answer, but at least we can start a discussion. So this is a picture of the store in TF2, Team Fortress 2, Valve game. For those unfamiliar, Valve has in-game economies in Team Fortress 2, Dota, Counter-Strike, Steam, among the most successful in the history of video games. The reason this exists Well, the reason in-game items and Team Fortress exist, not because we had a brilliant idea, it's simply because players in the game on community servers were modifying their character's appearance, and they thought it looked cool. And we're like, okay, they like it, so we'll put it in the game. That's why how items got into TF2. And then we started adding the store and things like the community market and trading and kind of other things, not because we wanted to make money, but simply because we were curious if real-world economic theory applied to virtual economies. We wanted to put economists to the test. We were curious. That was it. The end result was, again, one of the most successful economies in the history of video games. The reason that Dota has in-game items, again, not because we wanted to make money, it's we wanted to know if what was working in Team Fortress worked somewhere else. We wanted to generalize. TF2, an attempt to generate theory. Dota, an attempt to generalize. These are both hallmarks of science. We just wanted to find out new things and ended up, doing it very successfully for the company as a consequence. This is the only graph in the talk, which is unusual for me. I usually like having a lot of them. So think about luck and skill, right? This is a common complaint in lots of games, right? People complain about games being too driven by luck, potentially too driven by skill. But these are somewhat hand-wavy, nebulous kind of like sources for complaints. It would be great if we had an objective way of measuring the amount of luck or skill in a game. So here is one. The x-axis is kind of an ELO disparity. So ELO, for those of you unfamiliar, is a term from chess, but essentially refers to your skill level. Games have ELO or ELO-like ratings, matchmaking ratings. So the x-axis is essentially Team A minus Team B and their ELO rating, right? And so left side of the graph, Team A is much worse than Team B. Right side of the graph, Team A is much better than Team B. The y-axis, vertical axis, is your expected win rate. And then let's talk about what the three lines are. So the blue line, middle line, is if you had an entirely luck-based game where skill didn't matter, right? It doesn't matter what the disparity is, if you're better or worse than somebody else, your expected win rate is 50% all across the board. The green line is what it would look like if a game was mostly skill-based, right? If you're going to win most of the time, right, when the other team is much better than you, you're going to lose. When you're much better than them, you're going to win, right? So it looks like the green line. The purple line is a combination. I think it's approximately 70% skill and 30% luck with some variability. So what you could do with this, right, so you can model this, right, you can compare it to what the actual distribution in your games looks like. You can see which line. I mean, we can model infinite lines. We can model where we want. You can see what the best fit is. And you can figure out, yeah, my game is actually 62% skill and 38% luck. Then you could see how that impacts or doesn't player perception and what they think about it. And then when you update your game, and maybe it changes to 63-37, how does that impact player perception, right? So like, this is another talk. This is, we could go for hours on this, but the notion of actually trying to turn somewhat abstract concepts, right, into something concrete and measurable, and something we can manipulate, and then observe the impacts of, right? This is how we get to theories, and how we better understand the impact, and how we make more informed design decisions. This is Dota. For those unfamiliar, people in Dota can sometimes be unpleasant to one another, as sometimes happens in games, right? So one thing I would love to, one area of research I would love to work on, right, is from reduce online toxicity. And so this is one thing I did in Dota. So Dota on the left, Dota has an end of match survey. Please rate the quality of the match 1 to 5 stars. Very, very useful. You can correlate that with a whole bunch of really interesting data, things that happen in the game. If you only get to ask one survey question, you can do amazing things with that. It's great. Not the point of this slide. Cognitive dissonance is a term from psychology that refers to the notion where if somebody is holding two conflicting notions in mind, it causes them distress. And they seek to resolve that distress by changing one of the thoughts they have in mind. Okay. So how do we use this and surveys in Dota to reduce online toxicity? I'm going to tell you in the next 90 seconds. So what I did was I added 2 other survey questions that would randomly appear after a match. Here's one. Please rate the quality of your teammates, 1 to 5 stars. A useful question, right? We could use that to kind of like, test our matchmaking, like satisfaction, whatever it ends up being. I didn't care. I only asked that question so I could ask this one, which is please rate your quality as a teammate. 1 to 5 stars, right? Okay, yeah, so people are getting it, right? So what happens, right? People have a self-serving bias, right? You want to say, honestly, I was a good teammate. However, if you know that you were not a good teammate, and not every troll does, but if you know that you were not a good teammate, right, you can't answer this question honestly. So you suffer cognitive dissonance, right? And you seek to resolve that dissonance by playing better, by playing kinder, so you can answer that question honestly. So we shipped this, just these 2 questions. All we did, right, no other changes to the game, waited 3 months, and so the way we measured toxicity in Dota, or one way is, if somebody's being a dick, you can click on their name and we get a report, and it's a great, kind of quantifiable metric of toxicity. We shipped this, and 3 weeks later, reports went down by about 12.5%, right? So across millions of games per day, millions of reports, right? So not because we did anything fancy, right? We just added 2 useful survey questions, right? And had millions of people had a better experience each day playing Dota, right? So we're like, okay, we're building up theories, right, of what can impact toxicity, why it occurs, right, and what things can we do as game designers, right, to hopefully improve it. All right, basically the last slide, we're almost there. Fun, right? I promise you a little bit, right? Everybody always asks, how do you measure fun, right? I don't know about you guys, I am not happy with a survey rating of fun. You may be, they're useful. What I would like is some measurable change in behavior, something that indicates fun. What would that be? We have lots of options. I don't have time to go through all of them, but I do want to take this opportunity to at least talk about one thing that I think is an interesting way of kind of attacking this problem, and it's when somebody has the ability or has the desire to voluntarily engage with your product. I think that is a wonderful definition of fun. And I'll tell you where this came from. When we would playtest games at Valve, and we playtest them as early as we could, as often as we could, at some point you have to make a decision, is this shippable? And how do you decide, right? This for sure, right, is more of an art, right, than a science. But the most informative piece of data we had was when a playtest was done, and the interviews were done, and the surveys were done, sometimes we would let people continue playing. And over time, more and more people would continue to play. They would say, can I keep playing? Right? It's even better than us giving them the chance. They would say, yeah, I want to keep playing. Can I? And that's when we knew, right? And so that voluntary decision to keep playing, it seems to me like a wonderful place to start, right? And things get complex, right? Games have lots of reasons. If somebody logs in every day, for a login bonus, right? You get a bunch of playtime, people correlate that with engagement, and they say maybe it's fun. Is that really fun, right? I mean, you can tell by my tone, I don't. But, right, what we need to do is figure out, what is a behavior that genuinely represents fun, right? And a voluntary decision to participate in an endeavor, an activity, in a game, that to me seems like a good place to start. And so you could think about, inside of a game, when somebody gets a reward, right, an extrinsic motivator, maybe we don't count any of the playtime before, when they're trying to acquire the reward. Maybe none of that matters. All we care about is what happens afterwards. When they've gotten the reward, do they decide to keep playing? That, to me, seems like, okay, maybe we could do some interesting work there. So we're at the end, right? This is my thesis. Game designs are hypotheses, right? They're not something you know. They're something you want to find out. So how many of you are game designers? That was a trick question. All of you are game designers. Right? So if there's any merit at all to the approach that that I'm speaking about, right, of trying to generate a science of game design and adding some new truths to the world, adding some underlying theories of why games are games and what makes them games and what makes them enjoyable, it's going to come from people like you. So I can't wait to see what you guys come up with. Thank you very much. That was exactly at 30 minutes. That was exactly at 30.
No, you're perfect. We won't have time.
Yeah, that's fine.
Someone said their new mantra is going to be, is it good hard or is it bad hard? So, so thank you for that, Mike. Mike is going to be at the break, and you can ask your questions to Mike. We're going to go on the break for a few minutes, and yeah, see you there. Thank you.